I'm currently on a generational run of partial derivatives on the channel, but instead of just rinsing and repeating, just so that we can drill into the younger people how to do partial derivatives, I'm going to show how to find the stationary points. So let's first do df/dx of this. So whenever you're doing partial derivatives, the terms that you're not differentiating, you hold them as constants. So for this one, we're just going to differentiate the x term. So that's going to be 2xy squared minus here, this is going to be 4xy minus 2y squared. So the x is being differentiated. This remains the same, plus 4y. Now let's do df/dy. We do exactly what we did here, except for we're now doing it to the y terms. So it's going to be 2x squared y minus 2x squared minus 4xy plus 4x. So now we want to find out the stationary points. So what we want to do is this is going to be equal to 0 and this is going to be equal to 0. If we divide everything by 2, I don't really want to write it all out again, so I'm just going to get rid of these. So this is going to become 2, that will disappear. This will disappear, this disappears, this becomes 2, and this becomes 2. So that means df/dx would be, if I take this, and let's say I take out all the y's, it's going to be xy minus 2x minus y plus 2 equals 0. So now y would equal 0, or if I'm going to now put this into two brackets because we've got essentially a pseudo quadratic here that looks like a quadratic, but it would be x minus y, y minus 2, which equals 0. Let's do the same for df/dy. It'd be pull out the x from here, and you would get xy minus x minus 2y plus 2, which equals 0. So that means we'd have x equals 0, or y minus 1 and x minus 2. So obviously if we expand this, we're just going to get this. So when y equals 0 for, let's say, df/dy, you're going to get 0 minus 1 x minus 2, which equals 0, because we've made it equal to 0. That's what you have to do to find the stationary points. So therefore, x would equal 2. We essentially have two solutions now, 0 and 0, and 2 and 0, but we're not done just yet. We know that x could also equal 1, because obviously x minus 1, x equals 1 is a solution when you expand the brackets up here. And you remove them and you just look at that and make that equal to 0. So when you have, when x equals 1, you can get, for the df/dy, you're going to get y minus 1 and then 1 minus 2 here. So that means you're going to get y minus 1, 1 minus 2, which equals 0. So therefore, y would equal 1. So that's another point. We've got this one. And then we also have another solution, which is y equals 2 over here. So let's now plug that in, and you're going to get 2 minus 1 into here, and x minus 2, which would equal 2. So we have 0 and 2, and 2 and 2. So we have 5 stationary points in total, and they are 0 and 0, 1 and 1, 2 and 0, 0 and 2, 2 and 2. Beautiful.